So welcome everybody. So tonight we're gonna talk about single implant placement at the posterior region using RealGUIDE, the implant software. So if you don't know me yet, welcome here. I'm David, the director of guided surgery division in Real-Time Dental Lab. So I speak for both desk guided kit and using co-diagnostics and RealGuide both software. So if you're interested in, feel free to reach out. So before we start, naturally the guided surgery stuff from here. I mean, I don't know if you guys, know this before. This is actually a floppy and it only carry about like 1.4 like megabyte. It's less than a photo today. So this is actually how where guided surgery all started. So it's being invented by this gentleman right here. His name is Dr. Scott Gans, and he actually is one of our pioneer when it comes to guided surgery. And then has he has a like a textbook when it comes to guided surgery that's called computer guided applications. And this book has been translated in Chinese in China by this doctor, Dr. Anderson Sao. And he has to be, my mentor right there. So actually, I'm the one, try to connect the dots, to put all things together and then help them to translate the book in China. So back in the day, that actually I don't even know how many teeth are there in the human mouth. I mean, that's crazy, right? So I started working as a content creator for my mentor, Dr. Anderson Sao, and then just take some photo, video for him. And then, he just taught me hand by hand and how to map the nerve. And then when he, do the surgical dissection, he after surgery, he go back to the computer and showing me, hey, this is what happened during the surgery. This is what we were looking at. So this is how I, get into this field by not in the back of a computer, but actually on the surgical side. So he has a, small lab in a dental office, like a 3D printer, guided surgery planning software, even with the dynamic navigation system right there. So I have the privilege, to see how to design with my mentor how the implant surgery should go, and then I have the privilege to see what happens, how it works in the real case scenario. And then yeah, this is how I get started. And then I moved to California about 7 years ago, working as a surgical planning specialist there. And then that's where I met my mentor, Dr. Brandon Cover. He's a board certified prosthodontist in North Carolina, and then he brought me here in Cary, North Carolina, and he owned a lab, which is the real-time dental lab, the lab that I work for. So imagine you're working in a lab with prosthodontists in your back oversee, what is he thinking, what should be done, what could be done better. This is kind of another level of, oh, this is how everything works, prosthetic drivenly, right? So we have, a lot of, talented people there. So that I learned a lot from them. So this is the two major doctor, Dr. Brendan Cover and Dr. Kevin Lin, that I work with them like very closely, majority like day by day. So what's their mentality, what's their treatment plan looks like, how they adjust and tweak the implant position, and then finally comes to me to design the guide, and I was able to be there to see how the surgery really goes, and then be there to see the long-term outcome of the surgery. This is awesome, awesome. So this is basically who I am and what I'm doing right now. Okay, so today's thing is nothing too fancy, just step by step. we're gonna do a single molar implant, how to plan them using RealGUIDE from start to finish, right? So before we start, I would always like to show, the case. I mean, there's the implant place. Sometimes they are not at the right location, so I've seen this a lot. I mean, if you're in a lab long enough, you're gonna see these type of cases once in a while. So you always, remind me this phrase, very important quote. That is, if you fail to plan, you are planning to fail. And I cannot agree anymore with that. That is so true. So, and then because they're both prosthodontists, so I learned, to plan the implant, you're not only looking into the bone, but actually you're looking for the restoration. So that's what we called restoration-driven implant planning. So there's a very interesting phrase right here. So like some doctor will say, hey, the tissue is the issue, but the bone sets the tone, right? I mean, that makes sense. You have to follow the bone, and then, but uh, once alone, I learned from my doctor working with other oral surgeons. They are very, very phenomenal, great surgeon locally here. One time, he's placing a zygomatic implant. I mean, that's one of the no, that's the hardest implant that you can place, right, in the oral cavity. And then, the oral surgeons just, and my prosthodontist is there also. And then after the oral surgeon placed the zygomatic implant, and that oral surgeon just, raise his head, looking at my doctor. He say, "Hey, doctor, are you happy with the position of the implant? Can we proceed like this?" That's the moment I realized, okay, even though highly, skilled oral surgeon, still, yeah, respect the restoration a lot. So that's the second phrase, after the bone sets the tone, but the pros is the boss. Very interesting. All right. So after we know our goal, which is, the where the crown should be, and then that leads us to, okay, this is the wing implant should be, right? So after you have your goal, there are actually different ways nowadays today that we can go with the surgery. The first one is, of course, the freehand, right? I mean, you have your plan in your mind and you proceed with freehand, right? And the other thing is called out of bounds guy. Is basically like either a suck down or a clear duplicate of a denture, open a trough or some site, on a, if it's a single, right? A suck down with a hole, and I mean, that hole doesn't hold your implant drill, but it tells you where the restoration teeth is going in the tooth, where that belong, right? So that will guide you somewhere there. So that's called out of bounds guide. So the other one, of course, is what we're talking about today is called static guide, which is another name for that is surgical guide. So it's designed with the computer looking at down below the CT scan, and we will fabricate a sitting jig to hold a guided sleeve, and that sleeve will hold your guided instrument in place to help you to transfer your implant planning to the patient. So of course there are two more fancier thing. One is called dynamic navigation. So that's basically a just attached to your handpiece. So the doctor, when they move the handpiece, there will be a computer screen on your side. So it just shows you the cross-sectional view down there. Follow your drill. This is very useful. You would, simultaneously to see what your bone looks like down there. The other thing is the dynamic navigation doesn't lock you in place. It's not like a surgical guide. So you're gonna hold your own hand, kind of like a free hand, but you have the chance to see what's down below. So on top of that will be robotic surgery. So robotic surgery, basically you plan the implant in the software and then connect to the patient. And then when the surgeon, the doctor hold the arm and lock in place, the robot arm will lock you the trajectory three-dimensionally, right? You can move anywhere rather than up and down. So you can only drill to certain trajectory. So it's basically invisible surgical guide, basically like that. So this is, dynamic navigation and Yomi, the robotic surgery. But what we're talking today, after all these things, I mean, Dr. Culver owns all these fancy equipment. So one of his go-to guided surgery is still surgical guide. That's the majority time that he will like to use, and that tells you a lot. All right. So what basically is a surgical guide before we jump into the demo? So it's basically we plant the implant in the bone, right? Follow the restoration space, and then we design the guy on a model, right? So we plant the implant in the CT scan, and we design the surgical guide on an STL file, which is the model. So that will be very important thing I'm gonna show you guys later is two scans has to merge correctly to proceed. That's very, very important step. And then so after the implant placement, so we can attach a visual guided sleeve in the software. So everything we do, planning in the bone will relatively create a guided sleeve on top of the implant long axis, right? And then after that, we just need to create a sitting jig to hold that sleeve in place. So what is a surgical guide? So a surgical guide is just a sitting jig for the guided sleeve, right? So all we need to do is to design the sleeve right, and then we're gonna design the sitting jig right. So your surgical guide will be designed right, right? So this is a clinical photo from Dr. Kevin Lin, right? So this is tools supported guide. So the surgical guide basically sits on the tools. It's like a sitting jig, right? And then you can see the middle three guided sleep position. So they are being designed in the software, and then you will guide the drill go through that to into the bone, so we can transfer the planning in from a computer into the patient's mouth. This is basically what that works, right? So if you can only bring one knowledge home today, this is it. That the guided surgery is not 100% accurate. And if you break it down, follow me the especially planning stage, you will know, okay, this is what could happen during guided surgery. So there will be basically couple, steps to make the guided surgery. The first, we're gonna do the data acquisition, right? Basically, we need to take the CT scan, we need to take the impression for the patient, and then, as you know, the impression could be not that accurate sometimes, right? Either the CT scan itself, they all have deviation, right? And when it comes to surgical guide design, we're gonna do a segmentation, and we need to do the merging. So the merging is, I would say the key of the overall accuracy of guided surgery, because you're gonna merge the same object, and that's true, but capture different ways, right? To put them together. So that will be deviation on the CT scan, and there will be deviation on the STL file. And when you try to merge to deviate the object, I mean, I have done, I don't really count them, maybe thousands, more than thousands, case of guided surgical guides. I mean, there's no way you'll get 100% accuracy when you do the immersion. I mean, we can do it very close, but they're just, very, almost impossible to get exact the mean accuracy right there. So we just need to respect all that, right? And then that would be surgical guide fabrication. So the printing could get, deviated, and then post-processing, and then we're gonna cement the sleeve, right? So the sleeve cementation is, also could have a, some sort of, deviation happen. And of course, when it comes to surgery, your flap, your guide sitting during surgery, if you are passive of not passive to the guided sleep, they all, comes into all the deviation in guided surgery. So guided surgery is not 100% accurate because the deviation just systematic. It happens in every step, and we will look into that diving real quick deeper later. So to design a guide, basically there are three types of surgical guide. So the first one, the easiest one to make, is the tooth supported guide. So the tooth supported guide, it just means the surgical guide basically sits on the tooth, right? And then when the tooth is so gone, you have no tooth to sit on. There's another type of guide that you can use, which is the mucosa supported guide, basically like a denture or a base plate, right? That sits on the mucosa, right? So, and there's another harder guide to design that is called bone supported guide, meaning you flap the tissue and you design a guide based on the model of the bone, which is the segmentation that we generate from the CT scan, so we can make a guide out of it. So that's majority three major different types of guides that we can make. So today we're gonna focusing on the two supported guide, the easiest one. All right, so that's basically the workflow today. So first, we're gonna do the segmentation. So the segmentation, basically, this is a way we, convert the digital stacking, images into a 3D model. That's called segmentation, usually done in a, guided software. And then the other thing, we'll use that segmentation to merge with a patient's model. And the third thing is the wax up, restoration driven. Remember that. Just design where the tooth is going to be, and start from there. We do our planning in the bone, seeing CT scan, and use the tools to guide our trajectory where the implant should go. And after that, we place the guided sleeve inside. Then we generate sitting jig, which is the surgical guide to sit down the guy. All right. So without further ado, let's dive right into the live demo. Single implant placement using RealGUIDE software. All right. So let me stop sharing from this screen and let me share from my other computer. There we go. I think, yeah, that should be okay to proceed. All right. So basically, this is the real guys software. So if you guys never used this before, I mean, don't be scared. I mean, this is a lot of button, a lot of control here and there, so many things. So don't be afraid. I'm here. This is why we're here today, doing the baby step. How to get there using the software. So basically, if you can see here, we break it down. The left side right here, the white column right there, that's basically the workflow that we just basically follow that from the first step and all the way, maybe somewhere to the guide design, and that's it. Just follow, that's the workflow. All right. So rather than the workflow, and you can see somewhere here that's called object, column. This is all the thing that implant or STO file or the tooth will shows up. And then there will be, tools and items on top of this column right there. So based on different, workflow, you will see those tools are changing, right? So we can just follow the flow, and here's the, control panel, and then we just use the function on top of it. All right. So So this is after we imported CT scan and imported STL file. As you can see here, they are not aligned at all. This so we're gonna do the alignment. So before we start, we can, if the CT scan is too large, you can turn this on, this is called trimming. If you want to trim, any unnecessary part, like you're doing lower, you can trim this off, right? Like that. So that will be easier for you to see, right? So, I mean, you can trim it or just leave it like that because we can turn it off anytime. And then that's that. So we can go to the next step by pressing here or press the next step right here. So let's hit next. So this step is called 3D setting. This is basically letting the software know, okay, what threshold, I want the 3D to show. Let me show you. So if you, drag here, it will show some more, less bone density, and you drag there, it will show some more density right there. So basically just this right here, our default one is the bone. So you just select it usually is auto selected already. So if you want to, tweak it a little bit, this is your tool that I can use. And then that will be you can click on this one. This is called teeth, but this is being dragged to high density. You can change it to higher level. So now you can see the crown and roots easily, right? And then there's another thing called X-ray. And then if it's too bright, you just, adjust the brightness. So it's just basically, it will call out the 3D X-ray for you. You can see that. Very cool. And then this is my favorite, they can do soft tissue also. Oh my God. How cool is that? So CT scan is not only can show you the bone, it can also show you the soft tissue also. Very cool. All right. So if we are all happy with the setting, let's just hit next. And then now we see here, this is called import a 3D object, right? So we just hit import and then just bring in our CD STL file right here. So because nowadays, usually when we do the matching, that's hit match. So we're gonna hit, STL match to DICOM scan, right? So that just hit OK to next steps. So in the past, we're gonna select because this, 3D model has been segmented. So you just, select what drop whatever by points, right? You hit that, just drop whatever points that's relatively, to the model itself. Let's drag that. And let's try that one right here. And then let's try this one right here. And then let's try this one right here. And then we can just hit bit points. And now you can see after the feeding point, oh yeah, I mean, see, now this is a perfect example that tells you, this is some deviation happened. As you can tell, I mean, the teeth is not perfectly aligned. So in this case scenario, if you still proceed with a guy's design based on what the merge is gonna be deviated. Very, very, very dangerous. So if that happened to you can try to hit, best fit. So wow, I mean, in the software, that basically just find its own way back, right? So we can scroll through. Yeah, I would say it's pretty good merging right there. Maybe here are still, some, questionable area. So it offers us, different as views that we can view. Okay, maybe here we have some issue, the feeding is not, perfectly. So we can still, keep hitting the best fit, the software will try to find the best way to merge it back. So if not, you're not happy with that, you can also drag this, to merge your position of your model merging. So that's actually back in the day how we do the merging. So because nowadays we have AI function, right? So RealGUIDE also provide us a very good function right here. It's called assisted. So this is AI assisted automatic merging. So if you would just click into that, so let the computer do its own thing. And the computer will just try to load, to see where is the best fit. Okay, now you can see it's basically attached to the 3D model already. So let's see that. Say, wow, he basically provide a pretty good fit, right? Good here and there. Let's see from the coronal view. So we can see both sides. Even you see the soft tissue here where the implant is gonna be, going to be the number 19 area. It provides a pretty good fit right here and there. And then we can see from that, axial view to scroll through. I mean, still could be better here and there, but usually when it's a real case, the majority time I'll spend is at this step, just to check we have the best fit because this is super important. And then since we're just doing demo right here, so I'm not gonna go too crazy about this at this step. Let's just say we're happy with this, so that just hit apply. So the most important part that just been done, the merging to the STL to the CT scan just been done like this. All right. So that's heat next. So next step is called panoramic curve, right? So panoramic curve is basically just cut the bone, along with the arch that we are working. So because we have, AI function today, so all you need to do is just select the mandible and then just hit assisted, and then the software will just automatically draw the occlusal plan based on the occlusal plan, and then draw the panoramic curve for us. So later on we can use that panoramic curve to see our panel view, and then of course we will have a perfect cut our cross sectional view, which is critical when we design implant placement. All right. See, so the software just basically did its job, right? So what we need to do is to check. So the occlusal plan, if you're not happy with that, we can still adjust it a little bit. And then if you want to see the if we you can see, the can, the right or left, just try to make it as much, parallel um to the jaw as possible. And then if you want to do some fine tweaking, you want the, nerve canal to show more accurately, you can still tweak in the position of it. And then if you see, your field of view is, for example, right here is too narrow, all you need to do is click on the increasing panoramic curve region. If you click that, you will see, okay, we got wider, taller, and taller field of view, FOV, right? Awesome. I'll say that's a pretty good, panoramic curve. And say we're happy with that. So that's here next. All right. So here we need to drop mapping the nerve, right? So in the past, you gotta, scroll through to find your nerve canal and then just drill and drop it down one by one. Today, we still got AI function right here, which is, I mean, incredible, right? So all you need to do is just, just hit, detect the nerve. So the nerve will be detected automatically. So after you hit that, this is basically what you will get, the nerve canal just basically, being mapped based on the, auto detection, which is beautiful. All right. So after we have all that, I think the next thing is restoration driven, the wax up, right? Very important thing right here. So let's see. Let's clear all measurement right here. All right. So if you would, we can click on this. So this cross right here is actually hide, the CT scan because we just need to do a wax up here, right? So what to do is create a wax up and then select the tooth that we want to work and just hit OK, right? And next, the computer will, goes into, CAD design module. So you just drop your landmark on number 19. Let's say we're happy with that. And then the teeth is just put it there. And of course, if you want to adjust the position and the size of it, I mean, yeah, at this point you'll say, I mean, why not use is that AI tool to do this step? I mean, the good news, yes, there is going to be, the AI, designing tools module real quick, but it's not released yet, but it's coming, guys. Very cool. All right. So if you want to adjust, the position or the size of that, just, use this active widget. So if you click there, I drag here, you will change the size. If you drag there, you will change the position. If you drag that, you will change the orientation, right? So at this point, you just, put your crown at a, ideal position. Let's see. So let's try to measure from the other side. Let's see. If you want to measure, there's a ruler tool right here. And then just select the distance and then measure it from the other side. It's about, okay, 10 millimeter from the other side, right? So what we need to do here is just to, put the size of the molar, or sorry, I used the wrong tool right here. Let me delete that real quick. All right, so that's distance. So let's measure from that to 10. All right, so that's the size of the molar that we want. And then just we change the size, of course, the distance of it. So this step, what tells us, okay, where is the, occlusal table, of that tooth. So you can reorientate, the widget to design the crown. So let's try to follow the arch, right? You can see the arch here is not that usual. Not patient is created equal, right? And then of course the vertical height, right? So the occlusal height basically were there. So yeah, if you want to design this step like more accurately, I do recommend to get the when you do the data acquisition, get the opposing also, right? So you will have a better chance to design a pretty ideal occlusion, and then of course you can check your vertical clearance for your crown basically. All right. So let's say we're happy with the crown design. Let's turn that off and let's give it a global view again. So here, if you toggle that, you can turn off the measurement and let's try to feel, okay, are we on the right position? Maybe it's not, on a perfect ridge. If you use a global view to see your contact, you know, your long axis of your adjacent and everything. Of course, the arch form, right? Yeah. So let's just say we're pretty happy with that. All right. So let's move on. Next step. Okay, so now looking back to the CT scan, oh, now you can see. So this patient has his arch form is kind of like going um to the lingual side, palatal side a lot. So here, if you want to tweak the tooth like a crossbite, you can still do that, right? So so that's basically the teeth setup. Let's move on to the next step. So after everything, has been, planned. So here you see, how come the panel view looks like awkward, like it only had a single slice. Don't be afraid, just, hit here. That's the thickness that we can, design. You can just select whatever, like 10 millimeters. See, this is wider. or you can select a 20 millimeter. You can see more, right? Just so you can, this is basically tell the, software how many layer you want it to layer up, right? So just select accordingly. So see, so the right side here, this is a nerve, objects. You can turn it on and off, right? So now, because we draw the panoramic curve, so you can see the upper right corner, the view right here. This is a very good, cross-sectional view and tells you, okay, where we are, right? And if you want to see relatively to the on the CT scan, there's a, toggle right here. If you just click that, okay, it tells you where you are, three-dimensionally. You can either, change the trajectory of the slice. So you will have, and then you can rotate it also, right? So you can see the bone and the crown, and then, that's giving a nice, 90-degree, cut right there. So that's a beautiful, perfect, slice right there that we can, see. This is basically the bone that we're gonna work on today. So we just before we start, we can do a ruler to measure from the top of the bone to the top of the nerve. We got 21 millimeter of bone. That is not easy to get. I mean, wow, a lot of volume right there. And then you can also measure the width of it. So it's about 10 millimeters. So this is a great case, to do a implant because we have a lot of bone, right? So let's clean that. And then to drop an implant into planning, just hit a tooth number right there. Let's hit number 19. And then now we can select a implant that we want to use. Let's say today we trying to do a maybe Nobel implant. All right. So usually people like to use active. And here we can either use because the big molar, right? We can either go all the way to the RP, right? Oh, that's a big molar. Or if you're not, going to go too crazy, about the diameter, maybe 5 by 10, even 5 by 13. I mean, we have all the bone, right? You can call at at this time. So just basically whatever you want, right? So then just, put a default one like a, 5 by 10, pretty good, molar implant. All right. So let's see. We're happy with that. So, all right. So let's drop the implant in real quick. All right. So the implant is just been drop it in, right, in the position. And now we just need to, we can turn this off, right? And we can turn that off also. Then we can change the trajectory. Just use the left mouse button. So we can change the trajectory. And any, object here, you want to go transparency, just right click and click on, the transparency volume so you can see, okay, this is what we're working with, right? And then we just, so posterior single implant, we try to aim for the dead center of that molar, meaning the occlusal table, right? And then, of course, if you could, try to aim your trajectory to the, functional cusps from the adjacent, right? That will give you a vertical load on the implant. Implant doesn't like lateral, forces. They like, mean parallel forces. That's, the go-to way to plan it, right? So we can, go to here and then select on your implant, and you can look at the implant 360-degree, like barcolingual, mesial distal. I mean, yeah, that looks great, right? So you can either, change the trajectory a little bit. So let's say, okay, so I want to see the, the tooth in, the 3D view. You can either turn this on. Okay, that's looking at the bone. So if you want to look at the tooth, you can either turn this. Okay, this is the, relation for that. So there's more, even a better way to visualize the root, which is right here. There's a called torcal segmentation. It can allow you to segmentate the clinical crown, the crown with the root, or the bone, right? So let's try to create a crown with the root. Let's hit that. So usually, I would like to see the adjacent roots, which is number 20. So all you need to do just select your number 20 and then select on your panoramic curve, right? And then you will just, segmentate the tools for you. This is also an AI function. I mean, how cool is that? I mean, back in the day, it could take me about like 10, maybe 30 minutes to generate, a segmentation of a route. So nowadays, it's so easy. So let's see, we happy with that. Let's hit finalize. So you will just ask you if you want to save that object. Let's say yes. And then, yeah. And then when we go back, then we can see the visualized where the root is. And then we can either, go change the transparency of the model so we can see, okay, are we parallel to the adjacent root? And what's the distance between them, right? You can measure that also, which is, this is not an issue here, but just showing you how, usually how we need to do from the PDL to the implant. I mean, we got more than enough. That's great. So the minimum distance between roots is 1.5. All right. So knowing all these, so we are looking at you can either let's say Nobel if you want to maybe you can try a little like subcrestal you can do it also or you want to do it bone level you can do it also right so all that you just here you measure from your the top of the implant to the soft tissue so it's usually you look for 2.5 or to 3 millimeter around that the depth so it allow you to have the chance to create a great emergence profile around it. It's not, for example, if the implant is like this, like too shallow, let's say something like that, and your crown might have a very sharp turn, like a shelf, right? That is not good for emergence profile for the, let's say the biological width, right? The connective tissue, the epithelium, right, around it that could seal, the implant around it, the abutment, right? So the proper depth about like 3 to 5, 3 millimeter is a great depth for for longevity. All right, so now we have these, the trajectory looks good. Let's say we can change the trajectory here also. Let's say we're happy with that. So we can go to the, the two, we turn it off, and then we can see how that looks, relatively to the nerve, the adjacent root, and to the model itself. And of course, if you would, you can see, okay, what does it looks on a bone, right? So if you want to see the bone, there's a function for you to do it also, right? So you can go to this function right here. This is called bone segmentation, right? So we can have the chance to see, hey, okay, what's the ridge looks like, three-dimensionally. So basically, this is done by AI also, right? I mean, this is amazing. You can either, take out the root and whatsoever, right, and then generate the bone right here. This is very cool. And usually you see that pattern, you just, use a smooth tool, to smooth it down a little bit. Now we just go back to the software and we save the segmentation. And here we back again. Now, so we turn this off. We can change the color to whatever you like, and then you can toggle the transparency. Now you can see, okay, this is the implant looks relatively to the bone. So this is for the bone model, just for visualization only to determine if you're in the bone or where are you. The best way is still go to the CT scan. Just keep that in mind. Very important. All right. So let's see the crown. I think we can push the implant to buckle a little more, right? And then we can, use this tool to see, okay, this is what we are aiming for. Okay. All right. So the next step, so basically everything is almost ready. Let's say you're happy with it, how the implant looks in the bone, how it looks relatively to the crown, to the adjacent root. And the next step is to design a surgical guide, right? So to do that, uh, as that's a traditional, guided sleeve, it's usually like a cylinder, right? As you can see right here. So it's both sides. And since it's a posterior implant placement, I mean, I've been seeing, case like this when, the surgical guide has been put it in, and then, the guided drill try to fit it in, and the opposing teeth is stopping, is in our way, for everything to fit into the guide, right? I mean, that sucks, right? If that happens. So, I mean, we spend all this time try to, design a guide because, the guided drill compared to a regular drill, the guided drill has a guided portion, right? So the guided drill is usually longer than a traditional drill. I mean, so that's even harder, Imagine a longer guided drill attached to your handpiece, and your handpiece takes some vertical space as well. And then you have the patient with a limited opening, right? So that when the patient open their mouth, it doesn't open like up and down, right? It's like a hinge like this, right? So the more posteriorly, the less vertical space that we'll have. I mean, and it's just what it is, right? So sometimes it's very hard, to fit everything in the back. So the best practice, before we proceed with the guided surgery, is to measure the vertical clearance to see if the patient is eligible for guided surgery. How to do that? Just take out one of your guided rail and try to fit in the back of the patient's mouth, and you will see, okay, what's the length of the drill that I can fit in the back. That's, I mean, before proceed with the guided surgery, this is the first visit when you do the data acquisition. This should be done, based on the patient's jaw opening. So let's say or a sleeve, like a cylinder in the back. Usually, lattice has a less room, to work with because the guided drill has to go in, right? And you have couple solution for that. Is the first one is try to start with the drill with a shorter one and start your osteotomy first, and then use a longer drill because you have some osteotomy site, right? And then sometimes you can feed a longer drill after, or you start, the shorter one and then take out the guy. You have the initial pilot, drill, right? You just freehand from there, follow the initial trajectory, or we can use, the guided drill to put it in the surgical guide first, right? So you don't have to climb into that guided sleeve and then in the back of the patient mouth, right? So you put it into the surgical guide first and then have the patient wear the surgical guide after. Sometimes that works. So if those still doesn't work and you still want to proceed with a surgical guide, here's another solution that, the desk guided kit really shines. So let me show you how. So rather than use a regular sleeve, here we hit change. If you go here, the sleeve selection right here, you hit here, it will shows you, all sleeve system in real guide. Let's look for dynamic abutment, right? So they offer two type of sleeve. The first one is the regular sleeve. Another sleeve is called a cut sleeve. So if you after you select that, let's go inside to see what that looks like. All right, as you can see right here, a cut sleeve has a side opening, on the sleeve itself. So this is, very useful, because it give you more clearance for your drill to go, like a lateral access to go into the guided sleeve, right? That is awesome. So now you might ask me, hey, David, this opening is at the back. Is there a chance that we can change the orientation for that? Yeah, that's the good news is yes, you can just drag here and then change the angulation with that using this. You can see that the implant and guided sleeve is rotating, right? So now you can either rotate your lateral axis either from the buckle. Usually this is what a doctor likes to do, or you still placing in the lingual if you would, right? Lingual side is another way for the drill to fit in if that's easier depending your left-handed or right-handed, or you can put it in the back, right? A slide from the back, or you can put it in the front also, right? To give you a better chance, just fit right in from outside of the mouse, right? I mean, just at this point, just be your preferences, right? So you can talk to your doctor. What's your preferences? So usually our doctor like a lateral access from basically from the buccal side. All right. So yeah, so everything is done. So everything we done here now. Let's see, we map the nerve, we do the merging, and we do the clinical crown of that, and then everything we do at the end, it just gives us a position of a guided sleeve relatively to the patient's teeth, right? So we plan an implant in a CT scan, and we do we will generate a syringic later based on the tools and the sleeve position that we have, so this is very important. Now you will know the merging. If you deviate that, your implant is in the bone, but the merging is off. I mean, the deviation is gonna be, I mean, critical. You don't want that happen. All right, so to design a guide that's hit safe, if you would. All right, so the guide design module is right here. You can see this is called guide design. Let's hit that. All right. So if you want to see the sleeve, so this step is when it comes to guide design because it's a removable appliances, right? As any removable appliances, one key factor is super important. And that is the path of insertion, right? So this step right here is best basically tells the software where the path of insertion of the surgical guide is going to be, right? So basically, my preferences is trying to align for the bicuspid area. Try to see the survey line, cover here and there, and anteriorities. Yeah, we basically cover everything here. And then if you want to see the guided sleeve, you can turn it on also. And if you're happy with that, just hit set insertion direction from the view, and then just hit that. All right. So now you see that is the insertion direction. So now every color that you see, color surface is gonna be blocked out undercut, right? So the guide surgical guide, because the undercut has been all blocked out, it will have no problem with sitting in. And the good thing about one of the good thing about real guide is you can hit generate the undercut, so it will generate an undercut model. See that? So the undercut, just been generated based on the, path of insertion that we selected right there, right? So this is the master model that we're gonna design a surgical guide on. All right, let's hit next. So this step, is just letting the software know, hey, where I want a surgical guide to, set support. So basically, because we have all the remaining tooth, so I would say it will be good, to support all the teeth, here and there, and then we have some missing area at the soft tissue. It should be fine. We don't really need to cover that because the guy is gonna basically gonna be too supported. So basically, if you want to cover that, because the my preferences is usually go to the clinical crown portion. It's fine, if you cover more, it doesn't hurt. It just, will be more bulky, during the surgery. All right, here is some undercut, but there will be no problem, sitting the guy here because he's being all blocked out. And then let's keep dropping the dot, and then now we connect them. All right, so here I would like to have some soft tissue support. And then here, just for, the thickness for the guy. So I'll drag it down a little more here and there. All right. And then maybe a little more here to the cervical of the crown. And then it's fine tuning that. All right. So that's basically that I want. So that's heat generate the guy. All right, so now the sitting jig has just been, generated. So we can see here there's some, material here and there that could be the issue. So we need to fix that. So to do that, we just use a scope tool to scope it out, right? And hit apply. Voila! How cool is that, right? So we can, delete all the material that we don't need right here. Okay. And then there's a free-forming tool from RealGUIDE. This is awesome. If you, like to, you can smooth it down, make it a little nicer, like basically like playing wax right here. This is awesome too. I love this. Right. Okay. So if you're happy with the overall design, let's say we're pretty happy with that. Then the next thing is we're gonna create some, inspection window on the guy. Meaning we're gonna create some hole on the guy so we can see, during surgery, we can see if the guy is sitting down properly on the teeth, right? So this is called round window. So usually I would like to, open the round window, put it one on the anteriors. Now you can see, okay, this is, now the surgeon, the doctor can check, the fit on the guide at the anterior. Of course, I would like to drop another one at the posterior. This one's being, too shallow. Let's put it lower, right? So you can see that's in inspection window. And maybe let's drop one on the right side also, right? So if you can see here and here and here, three T's, is pretty much a good fit on the guide. That means your guide is being sitting down like very nicely, right? All right. So let's say we're happy with that. So we can hit next step. So the next step, because this guy has a site opening, right? As you can see, the software will auto-populate the the site uh axis like that. So we can, turn the transparency a little bit. So you have the axis, to go in from that angle in, right? So if you, want to maximize your, your sidewall, you can cut that material out also, right? So if you want to do that, let's go back to the guide design module. We can hit added existing guide right there. All right. So if you would like to, open a side window here, let's turn on the transparency and turn on the sleeve for easier, align. So you can use the scope tool, and then change the depth a little bit, about like 6.5 or something like that. And then set your scope tool to where, the cut sleeve is located at and hit apply. And now, voila, you just open a side, opening. That's easier for the, the guided sleeve to fit in. So yeah, this is basically how to, cut more on the side. As you can see here, now you have even more clearance, rather than a slope right there. Now you have free clearance to go in from the back. So that should give you, a pretty much, a good, fit of a surgical guy to go, everything in. So yeah, so that's basically what we, shared today at a designing, hands-on designing right there. So let me go back to my presentation here. Let's share the screen, desktop. All right. So that basically is the live demo about what we do, right? We do the segmentation and merging and the digital wax up. And based on the wax up, we do the implant planning and the surgical guide design itself, right? Very nice. And then this is, how to, plan, surgical guide using desk guided sleeve, right? So all you need to do, this is the guided sleeve. You attach to it and then you have the patient wear the guide, and then the guided sleeve, the purple one in the surgical guide, just hold the guided drill in place, and then you can drill to that position, to transfer your digital planning to the actual patient's mouth. So yeah, so that's basically what I have today for you guys. So code for cases. So if you have some cases you want to discuss, you want to have some question, have some issue, feel free, to just to send you all your essential material like CT scan and model STL to the, down below that email. And then if you would, you can, if you want to contact with me, please do. So this is my email and my social media. You can just feel free, during the day, you do your, baby step on your surgical guide design, you will, face some issues and problems, but I'm your resources. Just try to use me, just feel free to reach out. And then, yeah, I'm more than happy to answer your questions. All right. So thank you everybody today to join me tonight. It was very fun. So I'll see you next time.